Hearty welcome to the video series on Math Revision by Maticulous. Topic Continuity and Differentiability, Second Order Derivatives. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per video from selected topic is presented at this video series. The step-in answers are supported by the ideas used for getting the answers. Before we want to know about the second order derivative, let us recollect the rules on derivatives. If u and v are two real valued functions, u plus r minus v the whole dash is u dash plus r minus v dash. U into v the dash is the derivative of uv is u v dash plus v u dash. Keep the first, differentiate the second, plus keep the second, differentiate the first. Then this is quotient rule. U by v derivative is upon v square, v u dash minus u v dash upon v square. Denominator square, denominator into derivative of the numerator minus numerator into derivative of the denominator. We will also recollect the formula of derivatives very quickly. X power n into x power n minus 1, root x 1 by 2 root x, e power x, a power x log a, log x 1 by x, sin x, cos x minus sin x, tan x secant square x, cosecant x minus cosecant x cot x, secant x tan x, cot x minus cosecant square x, sin inverse x 1 by root 1 minus x square, cos inverse x minus 1 upon root 1 minus x square, and tan inverse x 1 upon 1 plus x square. Let us see what do you mean by second order derivative. Suppose for a function y is equal to f of x which is differentiable, the first order derivative is denoted by f dash of x or y dash or dy by dx or y1. All these notations you should know: f dash of x, y dash, dy by dx and y1. If the first order derivative is further differentiable, suppose if you are able to differentiate it again, then the second order derivative is denoted by f double dash y double dash d square y by dx square and y2. Now you should know what do you mean by d square y by dx square. It is the differentiation of dy by dx once again. Y double dash is differentiation of y dash once again. Y2 is differentiation of y1 once again. Well, you have to be very careful while you are doing the second order derivative. You have to follow certain method. After the first derivative, better simplify the expression and then differentiate it again to get the second derivative. Then only it will be easy for you to do the second derivative. And most important thing is to make it easy for the derivatives involving the functions log x, root x, sin inverse x, cos inverse x, tan inverse x. Simplify the first derivative by doing the cross multiplication and then find the second derivative. Why? Because log x will be 1 by x, root x is 1 by 2 root x, derivative I am talking about, sin inverse x 1 by root 1 minus x square, cos inverse minus 1 upon root 1 minus x square, tan inverse is 1 upon 1 plus x square. To avoid u by v form, cross multiply. Sometime what will happen? We will be asked to prove some equation at the end. After the second derivative, you have to prove an equation. When you are asked to prove an equation, do necessary substitution after the first derivative and then do the second derivative. It's easy for you to prove the result. Well, let us go to questions now. Y is given as root 3x plus 2. Prove that y into second derivative plus the first derivative the whole square is 0. Let us take y is equal to square root of 3x plus 2 and differentiation of root x is 1 by 2 root x into d by dx of 3x plus 2 using chain rule. Therefore, you are getting it as 3 upon 2 into root 3x plus 2. Before you start the second derivative, what I can do now? I can replace that square root of 3x plus 2 as y. It is given in the question. Now you do the cross multiplication. Y into dy by dx is equal to 3 by 2. Now let us, after the substitution, let us try the second derivative now. Keep y, differentiate dy by dx, plus keep dy by dx and differentiate y. Right hand side differentiation is 0. Clearly check out y into differentiation of dy by dx plus dy by dx into differentiation of y. What is d by dx of dy by dx? It is second derivative. Therefore, y into d square y by dx square. dy by dx is multiplied 2 times. Therefore, dy by dx the whole square is equal to 0. You see, after the first derivative, you have substituted square root of 3x plus 2 as y. Then only the problem is very easy. Go back to the next question. Y is equal to x power x. Prove that second derivative minus 1 by y into first derivative whole square minus y by x is equal to 0. You have been given x power x. All of you know this can be tackled only using logarithmic differentiation. Take log on both sides. Log y is equal to x log x. Power will come to the front. Left hand side differentiation is 1 by y into dy by dx. Right hand side using product rule. Keep x, differentiate log x plus log x into differentiation of x. Now all of you know that differentiation of log x is 1 by x. Therefore 1 by y into dy by dx is equal to 1 plus log x is the answer. Well, now we want to do the second derivative. Let us continue. I am multiplying that y because I want to avoid that 1 by y derivative. Therefore I am multiplying it to the right hand side, y into 1 plus log x. Again differentiated once again. Differentiation of the left hand side is d by dx of dy by dx. Right hand side keep y, differentiate 1 plus log x plus 1 plus log x into differentiation of y. Now once again, what's the differentiation of 1 plus log x? It is 0 plus 1 by x. Differentiation of y is differentiation of y with respect to x is dy by dx. Left hand side is d square y by dx square. Right hand side y by x plus 1 by y into dy by dx. I am replacing that 1 plus log x as from the first derivative, that is 1 by y into dy by dx. What will happen to you now? It will become d square y by dx square is equal to y by x plus 1 by y into dy by dx the whole square. Now you bring it to everything to one side. Therefore second derivative minus 1 by y into first derivative the whole square minus 1 by x is equal to 0. Here two things we have to keep it in mind. After the first derivative I have cross multiplied, brought the y to the right hand side. After that I have substituted for 1 plus log x as 1 by y into dy by dx. Then only you will get this equation directly. Well, let's go to the next question. Here y is equal to tan inverse x. They want the second derivative in terms of y alone. Normally when you do the second derivative on the right hand side, it is a explicit function. Our final answer will be in terms of x only. But they want it in y. Well, let us see how to do. Let us start y is equal to tan inverse x. Now I know that tan y is x. Therefore I am differentiating now. Left hand side secant square y into dy by dx. Right hand side differentiation is 1. Therefore dy by dx is nothing but 1 upon secant square y. What is 1 by secant square y? It is cos square y. Let us differentiate it once again. Left hand side differentiation is d by dx of dy by dx. Right hand side using chain rule 2 into cos y into d by dx of cos y. Once again, what is d by dx of cos y? It is minus sin y into dy by dx. Be careful. Again using differentiation of cos y. Therefore right hand side is nothing but minus 2 cos y into sin y into cos square y. Therefore the second derivative is minus 2 sin y into cos cube y. We have expressed the second derivative in terms of y alone. If the question is not asked like that, you can do second derivative by differentiating tan inverse x as 1 by 1 plus x square, and you can cross multiply and do it also. Well, let's go to the next question. Y is equal to a cos log x plus b sin log x. Prove that x square into second derivative plus x into first derivative plus y is equal to 0. Let us do the differentiation just like from left to right. Y1, I am using the y1 here because it is given in the question. A into cos of log x is minus sin log x into d by dx of log x plus b into cos of log x into d by dx of log x using chain rule. Now I got minus a sin log x by x plus b cos log x by x. Now already told you that whenever you are having log x like that, you have to multiply, cross multiply it, that is multiplying throughout by x. You will get xy1 is equal to minus a sin of log x plus b cos of log x. Again, let us take this and then continue with that. Left hand side x into y1, again differentiate it, keep x, differentiate y1, keep y1 and differentiate x. Right hand side differentiation as usual you have to use the chain rule, minus a sin of log x differentiation is cos log x into differentiation of log x. Differentiation of cos log x is minus sin log x into d by dx of log x. Please have more practice on this chain rule. Therefore left hand side is xy2 plus y1, right hand side differentiation 1 by x you have done it. Now once again x is coming, again multiply it throughout. Now left hand side will become x square y2 plus xy1. Right hand side when you take minus sign outside, it will become a cos log x plus b sin log x, which is nothing but y. Bring it everything to one side, you will get the equation. Here you be careful, after the first derivative you have to do the cross multiplication. After the second derivative, if you do the cross multiplication, you are getting the answer directly. Otherwise what will happen, you have to find y2 separately, y1 separately and put it in the equation and then solve it. That will become little bit lengthy. Therefore when you do the simplification after the first derivative, the problem will be easy. Let's move on to the next question. Y is equal to e power a sin inverse x. You have to prove 1 minus x square into second derivative minus x into first derivative minus a square y is equal to 0. Let us start. What is the differentiation of e power a sin inverse x? It is e power something, e power that into dy dx of the power, that is a sin inverse x using chain rule. What is the differentiation of sin inverse x? 1 by root 1 minus x square. Here I am getting 1 by root 1 minus x square in the denominator. Therefore multiply throughout, it will become square root of 1 minus x square into dy by dx is a into e power a sin inverse x. Let us continue. This to be differentiated again using uv form in the left hand side. Keep root 1 minus x square, differentiate dy by dx, plus keep dy by dx and differentiate root 1 minus x square. Right hand side differentiation once again, a into e power a power sin inverse x, e power a sin inverse x into d by dx of the power, that is a sin inverse x. Well, the differentiation is very easy now. Differentiation of square root is 1 minus 2 into square root of 1 minus x square, and differentiation of 1 minus x square once again using chain rule. The differentiation of sin inverse x is 1 by root 1 minus x square on the right hand side. For I have simplified it now. The differentiation of 1 minus x square is minus 2x. I have put it over there. Now this is the final stage where 2 and 2 are getting cancelled. Once again, root 1 minus x square is there in the denominators. What you have to do now? Again multiply throughout by root 1 minus x square. Root 1 minus x square into root 1 minus x square is 1 minus x square. Root 1 minus x square get cancelled with the second term and the term on the right hand side. And the right hand side is nothing but y. Therefore, you are getting the final answer. Here you are seeing very clearly that square root of 1 minus x square is multiplied throughout 2 times. Then you are getting automatically the equation involving derivatives. Okay, success is dependent on efforts. All the best. Thank you, friends.